Hi guys, welcome to Learn Electronics Repair. This video is kindly sponsored by PCBway, and we're going to talk about USB chargers, PD and fast chargers. I built a project a couple of months ago on the channel which was a USB load tester, and we can see that project here on PCBway.com. This load tester can load a USB power supply up to 35 watts. There is an original video on here. This is the original author. I will just show so we can see his channel. Credit where it is due. This is easy one. So if you want to see the project on the original channel, there it is. I actually built one of these previously and we tested it working. We were loading USB power supplies. But loading and testing PD or fast chargers is a different matter. There are more capabilities and more features of those chargers. Let me show you the load which I built. We can see it working, and then we can have a quick chat about why USB-C chargers in particular are likely to become ubiquitous. This is the project which I built using a PCB from PCBway.com. Here is one of the blank PCBs. If you're interested in this project on the original version, you can order some of these PCBs from PCBway.com. You get 5 of them for $5 plus postage. Postage depending on whether you use an express courier or a normal snail mail courier from China, shall we say the slow boat. It will cost you, well, for my location, maybe €6, $6 for postage, up to 25, depends how urgent I want them. Having said that, the slow boat only takes normally 13 to 16 days anyway, so it's not forever. You will also find in the description to this video a discount voucher for PCBway. If you are setting up a new account, you can use that voucher and you get $5 off your first order. Which means if you order something like these or similar, 5 PCBs, all you pay is the postage. And that's got to be an unbeatable deal, guys. So here is the one I built. You'll see this is modified slightly from the original one. The original one had the transistor on here. The reason for this, I discovered that the transistor was getting too hot at high current. This can load on a 5 volt USB, 35 watts at 7 amps, so that's quite some current going into the load. The little resistor you see here is actually feeding the second transistor on here, so I have 2 transistors in parallel, which basically means each one is dissipating about 17 watts each at full power, and you could add more. We'll talk about that later. Let me just show you the load working. So to use this, I'm going to connect an analyzer on here. This will show me the voltage and current. But again, we will talk about how to get around that so you don't have to buy this sort of equipment and still be able to monitor it. And I'm using a USB-C power supply, PD power supply. This is the one I repaired, guys. If you watched a few videos ago, I could link that video to this one. That's why it has the tape around it, because it's for me, not for a customer, okay? But this does work, so let's try it. I'll connect the load to the analyzer. Let's see what it does. Well, I guess to make it do anything, we need to switch it on. And there we have it. So you can see the power supply is giving 5.08 volts. It's drawing practically no current at the moment, almost no wattage, until we turn it up. You'll notice my power supply, the voltage drops on load. I've noticed this myself, by the way. And at maximum load, I can get about 4 amps out of it, which is basically the rating of this power supply, 16 watts of power. So that's the load in action, as you can see. And it's performing as the original author described. Now let's look how we can modify this, how we can improve it. Also, let's just have a quick talk about why USB-C is so important and why you're likely to see this much more in the future. Well, the thing about PD and USB-C is that there is an EU directive coming into action in 2024. And this says basically that all devices which use a charger or an external power supply must have USB-C by 2024. So manufacturers who want to sell their products into the EU market, which is massive, I don't know, 500 million people, something like that, is huge. So those devices will be manufactured for that market, which means, to be quite honest, that if you're buying the same device elsewhere in the world, it will have USB-C as well. There's no point really making a version with something else for somewhere else. It's cheaper to make one model. So without doubt, we're going to see a lot of USB-C chargers and power supplies and power banks and similar things. And these you may want to repair, or at least to test them, to understand them. If you have a problem, say, with a laptop, is it the power supply failing under load? Is it the laptop drawing too much power? These analyzers will tell you, because you can actually make a load and test the power supply. Even if you then throw it away, this will test it for you. Or you can go and repair it. So that's why we need this. Now, this load is very inexpensive. There's one IC, op-amp type IC, and a few more ports, transistor. This costs almost nothing. These analyzers, this is about 50 or 60 euros. It wasn't cheap. It has a lot of extra features, but for the basic features we use, it's a great tool, but it isn't cheap. There's another thing about USB PD chargers as well. This is a typical PD power supply, and I'm sure you've seen these before, and they have many voltages on here. 5 volt, 9, 12, 15, 20 volt at different currents, 100 watt max. And you may wonder, well, what output voltage is the power supply? I mean, there's no switch, there's no selector, nothing that you do to say what voltage comes out of it. If I plug a 5 volt device in, it happens to be outputting 20 volts, is it going to blow something up? Well, probably yes, it would. But these are smart devices. So these use a protocol called PD. And this protocol means that when you first connect a device to the power supply, it gives you the minimum voltage, 5 volts. And no matter whether it's a laptop that runs at 20 volts, it can still power from that 5 volts and then instruct the power supply to give it the voltage it wants, 20 volts, for example. So that's what PD does. And that's another thing we need to test with our load. To test this power supply, we need to be able to select the output voltage so we can test all of the parameters, or we can test the power supply at the same parameters that the device it's powering is using. So how do we do that? Well, what we do is we get an expert onto the matter. So guys, here is Det.
Did someone say USB PD?
Someone did say USB PD.
Hey guys. Hey nerds, I should say, yeah.
And I should have said hi already. So you can see Det is with me today. So we're going to talk about PD, how it works, and how we can implement this without an expensive device like this, which actually does have that facility, by the way. How we can add that to this load so it's built onto it, and while we're at it, how to add current, voltage and wattage meter to this as well. And then we have a little standalone device we can use to control our power supplies. We don't need to spend the money on buying this if we don't already have one, and we can call that the ghetto method. So
yeah, okay guys, yeah. USB PD will be anywhere, and PD, this is a abbreviation for power delivery. Power delivery, if you look around, there are some other protocols out there. There was a quick charge. This was something I think Samsung had their fingers in there, but they wanted to have royalties for that. And PD is free, so everybody can use this protocol. And this will be the VHS of protocols for USB.
Oh, so does that mean like it's not the best protocol It's just like the one everybody used, a bit like Betamax was better than VHS.
Don't get into this discussion.
Not on this video.
Not on this video. But actually, we're looking forward to USB PD 4. Currently is 3 on there. And 4 will be, of course, it will be better. Well, yeah, there are 2 ways to tell the source that you want to have some power. Actually, I had a video on my channel with a little USB-C to serial adapter, and the Chinese forgot a resistor on that, and the thing simply didn't work on my laptop. So, yeah. The analog way is to use a 5.1K resistor down to ground. Oh. So you tell the source, hey, I'm here, I'm a device, I want to have some power, give me 5 volts.
Did you show how to do that on your channel?
I have it on my channel.
Oh, okay, guys, I will link to Det's video on that so you can have a look at it.
Thanks, mate. Yeah. The analog way is the 5.1K resistor. You can't change the voltage there. This is always 5 volt. You can vary the resistor, and it tells the source how much current will be needed. You can tell it the 5.1K is somewhere 500 milli, I think, or 1 amp. So normally way enough for everything you throw at it.
So is this 5.1K resistor just wired between 2 pins on the USB connector?
Yeah, there is. USB-C has its intelligent protocol. There has the CC pins, control channel.
Yeah.
And you have to use them to tell the source, hey, I'm there. The reason why the USB to serial didn't work, my notebook has an intelligent controller in there. And as long as there's nothing on the CC channels, it doesn't put out any voltages there.
Okay. Yeah. So that's the basic way to tell the power supply, but you can only tell it to use 5 volts. Yeah. So how would you tell it to give you another voltage?
Yeah, this, as I said, this was the analog way. And of course, there's a digital way. But you can't do this without a little microcontroller. And for this, we have a way.
So what are these, Det?
The Chinese call them USB decoy, and don't ask me why they call them this. If you go on the usual sites and you search for a USB decoy, you'll find those little thingies over there.
So I can get some of these from AliExpress?
Yeah, and they're really not expensive. They're
how much?
Under $1.
Really? Oh, yeah. Okay. Yeah. So we have some different ones.
Yeah, we have some different ones because they come in different shapes and sizes. We went for some selection here. All of them do simply the same because they simply talk to the source. So what voltage do we want? They do this in different ways. This one over here is the easiest one to see how it's done because there are simply dip switches on there. And the other ones have a button here that switches the voltage. There's another button that switches the voltage. And this one has little tiny dip switches over there. Really cute ones. And yeah, they're pretty much doing all the same. But I think you guys want to see them in action. Should we do that?
Yeah, I think so. That's the best thing. Let's connect one up.
Yeah.
Let's do it. Okay, to do this, I'm going to use a power bank. You can see the ratings here. Again, this has the multiple voltages, like the power supply I was showing you. And we're going to use the decoy to switch the voltage. To see what's happening, we're going to use the multimeter to measure the output. Let's connect the power to the first one. You can see the voltmeter there. We have the decoy attached to the power supply, and of course it wants to go upside down. Let's just move them out of the way.
I always want to do that.
They always want to do that.
I'll hold this there and
it's okay.
You poke it.
Det suggests I poke the hole, but I am on there, so you can see. Of course, Det can't reach now to the button.
Yeah.
But we can see we have 5 volts coming out of the decoy. What happens when we press the button?
Let me do that. The important thing, the LED changes color.
Oh, yeah, red, yellowish green.
Yeah, and it puts out 9 volt.
Okay, and again.
And again. Green, and it's 12 volts.
It's like the spectrum, red, yellow, green. Do you have blue next?
Yeah. Let me see, yeah.
Oh, cyan. And I've just slipped off the thing. 15 volts, and this is going to be blue.
And now we have
of course
a real blue, and this is 20 volts.
It's 20 volts. And if you press it again, does it just go back to 5?
It goes back to 5.
Okay, so that's what a decoy does. That's what these devices actually do. Here's another one, different make, but the same thing. And I think I can actually reach the button on this one. No, every time I do it, the thing slips.
9 volts.
9 volts. So this one actually is just showing us on the display. So this is how PD works. We may as well look at the last two as well, then you can decide which type you prefer, of course. This is one with the switches on. Again, you can see we have 5 volts coming out of that one. All off gives us 5. We have to try the various options.
Yeah, I think so. Yeah, there was a schematic for that, but we have to look up the.
There was an
the
instruction
chip,
book
yeah.
which we lost.
Yeah.
That's still 5. Let's go through the binary progression, shall we? That's still 5.
Okay, this one.
That is binary of 3. That is still 5.
Hold it there. Unplug and replug. Maybe this needs a. No, it's
okay.
the same even if we start.
Well, that's 3. So let's go to position 4 in binary.
Yeah.
4 gives us 15 volts.
All right.
So this would be 5.
20 volts.
20 volts. 7. 9 volts.
9 volts. All right. This is a bit fiddly, but you can figure out in which position you should put it. And yeah. With a voltmeter, this is easy.
And I guess the beauty of this one, if you take the power off and back on, Det, unplug it. that
my part.
Det missed his cue there. Yes, it goes back to what you set it to, rather than having to press the button each time.
Actually, I know this from the little green PCB we had at first.
Yeah.
When you hold down the button and plug it in, you can set the output voltage by choosing the right color.
Okay.
This is a bit weird, I know this.
Yeah.
But you can choose the output voltage by choosing the color of the LED, and when you plug it in next time, it will keep the color.
Oh, it remembers.
We haven't checked this for the black PCB with the LEDs on top. But this is the easy way, because normally, you know, when you build something, you know what voltage you want to have, and you don't want to press a button.
Set the switch.
I would go for one of those.
Okay, so we have one more we can play with, which is the one with the tiny little
I think we have
dip
to
switches on.
remove the tape on the.
Oh, I see. This has like a little condom thing, or a little sheath.
Can you say that on YouTube?
I don't know. I've just said it. Let's see what happens.
The fiddly part is always yours. Yeah.
The fiddly part is what that's just done to my thumbnail.
Ow!
Ouch!
Ooh.
Yeah, we'll talk about that later.
Dead mirror neurons.
So we'll plug this one in, and again, let's see what we have. So we have a red light.
Oh, red lights. That's good.
Okay.
Nice one.
12 volts.
12 volts. All right.
And then we have to set the switches again.
I think so.
Tiny switches.
Yeah, really, really tiny ones.
20 volts.
20 volts.
Yeah, so this is a similar thing. We have different positions to give us different.
5 volts.
5 volts.
Nice. And one of them will be 9 volts.
5 volts on that one. So yeah,
it's the same play around.
It's the same play around with the
big
other one.
dips.
Yeah, to get the different voltages.
Yeah.
Okay, so you can see the principle of that one as well. I'm sure one setting gives you each voltage you want.
Yeah.
So that's the decoy.
That's the decoy, indeed, yeah. Okay. And this is the easiest way to have a voltage on your desktop other than 5 volts. 5 volts you get anywhere, but with this you can go up to 20 volts.
Yeah.
And since we're shown, we're currently using a power bank for that. Mm-hmm. So you have a power supply that delivers up to 20 volts and 5 amps if your source can handle that. This is 100 watt. This is a lot.
Excellent. And in a very compact size. Now we know how we're going to add the ability to switch the voltage of the power supply we're testing. Let's look at how we're going to do away with the requirements for this. How we can still display the voltage, current and wattage without spending another €50. And once again, it's over to Det.
Thank you. Well, we don't need much for that. We need the input voltage. So this is coming from PD. We can grab this directly.
Yeah.
There's already a current sense resistor. This is the R050 over there. Thank you. Thank you. Yeah. This is something 50 milliohms?
Yeah, 50 milliohms, yeah. So, guys, the way the current sense works, all the current that's passing through the load passes through this resistor back to ground. And because Ohm's law says that voltage equals current times resistance, there will be a voltage drop across this resistor that is proportional to the current flowing through it. The higher the current flowing through, the higher the voltage drop. And that is the second thing that you monitor with your microcontroller, yes?
Indeed, yeah. We only need a little analog to digital converter over there, ADC. And since we know the resistor, we can figure out how high the voltage will be and simply go for some math and the CPU. This is easy.
Oh, so with your microcontroller then, because you know the voltage across here and we know what the value of the resistor is, we can calculate what the current is.
Exactly.
Oh, okay.
Exactly, yeah.
And then the next step, guys, obviously we measure the voltage across the USB coming in. So we've now got the voltage, the current, and watts equals volts times current. And again, that's a bit of simple math.
Yeah. That's just power, yeah.
So how are we then going to display that? We use a little display?
I'd use a little, this little OLED display thingies? There are some tiny ones, 0.96 inches, something.
Oh, they're standard. I've seen those all over the place.
Really cheap. They're under $1, so this isn't really cost in here. And since you can buy them as a module, you don't have to do some soldering in there where you have to solder flexible PCBs or something. They are simply 4 pins and you're done. Okay,
and the microcontrollers, how much are those? Are they cheap?
About $1. I would go for some small 80 tiny one. So a 80 tiny 85 something is $1 maybe.
Oh, okay, yeah. So the idea is then to do what this does, or at least the main function that we want, just for $2-3 or something.
Yeah, maybe put in $1 more because we're going to need a voltage regulator.
Oh, yes.
Yeah, since we're coming from PD, we can't say, okay, we only have 5 volts. A 80 tiny 85 could work perfectly with 5 volts. But since we're coming from PD and now we have a voltage that can go up to 20 volts.
Yeah.
Maybe more if you use something else than PD. We need a voltage regulator here.
That's because the microcontroller would burn out.
Indeed.
When we increase the voltage input.
Yeah, indeed. Yeah.
Okay, that makes sense. So how we're going to modify this, guys, is we're actually going to do it using daughter boards. So this will be a modular thing. If you just need the load, you just build the load. If you want the ability to switch the output, voltage of the power supply, PD, you put the little PD module on. If you want the ability to monitor the voltage, current and wattage, you put that daughter board on.
Exactly.
Yeah, so that really makes us very flexible, and to be quite honest, because you have the connections onto those daughter boards, if you come up with some other smart idea you want to do, like data logging or similar, you have the connections, you can put your own daughter board on. So that's how we're going to modify this. There's one more thing we're going to add, and Det came up with this idea, was that we can put 2 banana sockets on here. These are the standard 4mm sockets like you have on a multimeter. And the idea is that we can use this to load other things other than USB. This then is the PCB that Det designed. You can see on here we have the connection here for the display board. This is the one that actually will have the volts, current and watts on. We have the voltage, VCC, that's coming in from the USB, and we have current sense, which is coming from the resistor, which we've actually moved to this side of the board.
Indeed.
Here. One other thing I didn't talk about, but you can see clearly on here, you can have 4 output transistors in parallel. It's optional. If you want to have more wattage, you can just put more transistors. You could build this using 2, populate any 2, and then if you find they're getting too hot, just add 2 more. Because of that, we also have 4 individual base resistors, 1 for each transistor. That actually balances the load, so each one is working equally. So that's what we've done there. The display board, the PD decoy just goes here. There are actually only 2 connections.
Indeed. The raster is so that we probably will use the 2 outer pins, and you see the little plus and the little minus, and this corresponds to the connections on the decoy boards.
And this connects directly to the USB socket?
Indeed, this is the same connection. Also the same connection as the big pads over there, the GND and the VCC. If you don't want to use any USB here, you simply have this big pads, exactly those 2, this big pads, where you simply can throw on some wires and have a go if you don't want to go for the USB part.
To load anything.
Yeah.
As Det came up with the idea, these 2 large holes, this is where the banana sockets will fit.
Indeed.
And you will also notice that we have some very thick, heavy tracks here. This is to carry the load of the current. And these tracks on the PCB are not solder masked.
Indeed.
So in fact, if you want to layer thick layers of solder on top of this to help with the current capacity, you can do so.
Yeah.
So that's our version of the load. We call it multi-load. And now we're going to upload this to PCBway.com and we're going to order some of these.
Yeah.
Hopefully within the next few weeks we can build one and we will test it for you guys. If it works well, this project is then there for you to download.
Indeed.
Ordering from PCBway.com is really easy, guys. You simply go to the website, PCBway.com, and you go to Instant Quote. From here, you will see there are lots and lots of options, but you don't have to worry about any of this stuff. This will sort itself out. All you need is the Gerber file. So, quick order PCB, add Gerber file. This is the one that Det built.
The Polish banana version, indeed.
Polish banana version. And there is our board. You can see both sides of it. We can now, if we want to, we can make some options. I like to use red because it's the channel color. Although the picture doesn't change here, we now have these PCBs in red, so they will arrive in red. We have various other finishes if we want to. We could, for example, increase the thickness of the copper.
That's a good idea. That's a really good idea because this will increase the current the track can use.
Yeah, so we can see now we have delivery to the USA. First of all, to do that, I will select my country, so I am in Spain. The cheapest option for me is global standard shipping. You see 9 to 13 business days, so the slow boat from China isn't exactly so slow, as long as the wind's blowing in the right direction. So we apply that. And you can see these PCBs are going to cost me $38.69. The main reason for that is the thickness of the copper. We just go for standard, $5.
Yeah.
But let's order some PCBs in the heavier tracks and we can have a look at them. When they arrive, we can have a look at these. So I now put this into my cart. I will now log in once I'm offline. Obviously with my credentials, I will log in and I will order these PCBs. And it's as simple as that, guys. So in a couple of weeks, or the most really, we will have our PCBs. Hope you enjoyed that from Det and myself. I hope you now know a little bit about USB-C and PD in particular, how it works. You know how to control the voltage of it so you can build your own projects using this. I'd like to once again thank PCBway for their sponsorship of the channel, enabling me to make these type of videos to show you guys. So from Det and myself, I'd just like to say ciao for now, guys.
Keep hacking.